Hello and welcome to CIS 4510 IT Project Management. In this session, we are going to talk about the data that's been collected or the information that's been collected in the last session or in the previous session. We are going to analyze it and evaluate the information. We are looking for reliable, accurate, and valid data. We are going to look at the distribution of the data. How does it look like? What are the patterns, different patterns that it follows? And we are going to look at centrality and dispersion. We are looking going to look at how to do data smoothing or moving average. Then we are going to see what are the different relation between the different variables that's being collected, and we are going to learn how to normalize data to benefit from that. So the importance of data analysis for the IT project is that it will allow optimal usage of project resources. We will know how to schedule, we will know how to assign resources to the proper activity. We will also identify the computing needs that we need to manage the different resources and different activities. And it depends on how much information do we have. We can build a database for that, and then we will have a database management system to do that. We need to identify processing requirements, and that will assist the data that's being collected will identify process requirements based on the information that's being gathered. We can also develop the proper IT project plan that will assist us in implementing and executing the proper IT project. It will assist in developing security plans if we are dealing with information, lots of information, whether organizational information or personal information. We need to secure that, and collecting the data, analyzing it will assist us in knowing which level of accessibility for each person in the organization. It will assist in cloud computing tasks and application. We will know what kind of tasks do we need, what kind of application do we need to implement in the organization to assist in other activities or other processes. It will also assist in project monitoring, keeping data within range. So we will have the activities being executed within the allotted time and within budget. And all this information will be through the analysis will give us a range, and from the range we will know that we are within limits or not. Before we collect data, we need to identify the proper sources, we need to determine methods for data collection, and we need to determine the method of data analysis, and then we need to determine how to process the data. After data collection, we need to know the computing resources to run the analysis, what kind of computing power we need. We need to know the human expertise needed for that, and we need to process data, prepare tables and graphs, then analyze and interpret the findings, and then prepare for presentation. When we say data reliability, accuracy, and validity, data that can be trusted, that's reliable, that we can depend on, and anyone should get the same results when running the experiment, and it will be more reliable if repeated and many readings or data points has been collected. The accuracy, of course we are looking for accurate data, so data values must be the right values and must be represented in a consistent and unambiguous form. For validation, data should be valid, which is making sure that it's relevant to the information that we are collecting, it's correct, and it's useful for our data collection or data analysis process. Once we get all the information, we will notice that it will follow certain distribution. We need to we need to draw, we need to make sure that there is a pattern. And what kind of pattern do we have? But if we got a shape like that, we call it the bell curve, and that is a normal distribution. We have other distributions that will be either skewed to the right or skewed to the left. Some of them are following different patterns, so we can look at the data, see what kind of distribution they follow, and based on that we can interpret the results to understand what kind of information or what kind of knowledge we can get from that. There are two types of analysis for the data, either descriptive analysis or inferential analysis. For the descriptive analysis, it refers to the description of data from a particular sample. So we take a sample, not the whole population, just take a representative sample from that population, and that sample should summarize data and describe sample characteristics. The numerical values obtained from the sample that gives meaning to the data collected, the overall collected data, and actually this sample should represent the whole population. So whatever we get from the sample about the different characteristics, those characteristics also belong to the whole population. The descriptive analysis provide us with central tendency, which is statistical index that describes the average of the set of values. And there are three kinds of averages. I think you took that before, either on the high school level before that, or in different classes in the math, which is the mode, the median, and the mean. And the mode is the numeric value in a distribution that occurs most frequently. The median is an index of average position in a distribution of numbers. And the mean is the point on the score scale that's equal to the sum of the scores divided by the total number of scores. So actually x average is equal to the summation of all x's divided by the number of scores or points that's being collected. One of the other things that we need to calculate or we need to look at is the variability in the measures. The collected data vary in the value from the planned or the expected one. So whatever we planned for, actually there is a little deviation from that. Data could lie within a given range. There is a certain range that will be given or that will be calculated, and the data will lie between those two points. The range is the distance between the highest and the lowest score in a distribution. Variability can be measured using standard deviation, and this is also something that you took before, and we know how to calculate that, which indicates the average to which the scores deviate from the mean. The other method is the inferential statistics, which is a numerical value that enable the researchers to draw conclusion about population based on the characteristics of a population sample, and this is based on the laws of probability. So we need to know the probability of something to happen in the execution, during the execution, or during the implementation phase. And as you can see in the figure here, the sample represents the population, and that's how we infer about the population and the characteristics of the population. One of the things that we use also, once we get the data, we can create what's called control chart. And a control chart is a chart that with time on the horizontal axis to plot values of statistics or statistic. Now the value, as we can see, we have upper limit and lower limit. So basically we are trying to see those values are within range or not. Whether we are talking about cost versus time, we are talking about other scheduling issues, everything that's related to the project can be drawn, and based on that we can decide or judge if the project is going as scheduled or not. The most important thing usually in the project to follow is the time and the cost, and that's why we have alerts or triggers that will trigger any outliers or any points that's out of the range. Like this point is considered out of the range, this point is considered out of the range, and as soon as we have something like that, then we need to take an action. That's why we say that we use the statistics or the control chart to tell us when we need a correction active or corrective action to be taken to adjust the results to be back within range. This chart is usually used to drive process improvement to make sure that we are as close as possible to the average. The upper and lower limits are the range of data variation, and any data out of range will trigger, as we said, will trigger an alarm or will trigger some kind of alert to the project managers to adjust and take the proper decision to adjust and stay within range. For the data, usually data are not like we said, they are far from the average, so they're not smooth, and there are lots of variations. So to smooth and get the data as close as possible to the average, we use what's called data smoothing. And data smoothing is a moving average that is a series in a series of arithmetic means, and it's used to get the points or the results as close as possible to the average. It provides overall impression of data over time, and it can be calculated by the summation of data from previous n periods divided by n, which is the number of periods. And this is an example for moving average, and we can see that this is a 3-month moving average. In the 3-month moving average, we look at the month of January, February, and March, and we divide by 3, and that will give me the average of the next month, which is April. So as if I'm predicting that April will get 11 and 2/3, it got 16. So I will calculate the next 3 months, which is 12, 13, and 16, divided by 3, and that will be 13, and so on, and that will give me as close as possible to the average data that's being collected. One of the other things that we need to look at is the relation between the different variables, and the relation between the different variables is called correlation. The correlation measures how strong is the linear relationship between these different variables. Correlation does not necessarily imply causality. We are not saying that x2 is causing x1 to happen, or x3 is causing x1 to happen. We are just looking for what kind of relation. Does the one increase because the other one increases, or does one decrease because the other one increases? And this is the type of relation that we are looking for, and based on that we have a coefficient of correlation that will measure the degree of association. The value of the correlation factor or coefficient varies from -1 to +1. And to understand more, those are the graphs that we can get, or the charts that we can get when we have correlation between x and y. So if we have a linear line like this one, we call it perfect positive correlation, and r at this point is equal to +1. So this is called correlation. And again, we are looking for the relationship between the different variables to see the effect of each variable on the other one. And that will assist in project monitoring and project control. It will assist in taking the proper decision on what to do, knowing that if a variable increases, the other variable will increase or decrease. This one, the other chart or the second chart, has a positive correlation, which is between 0 and 1, or between 0 and 1. And as we see, we have the points scattered around the line. So this is a perfect line, which represents positive correlation. This one is scattered points, and there's a line in the middle, and that's represent a positive correlation. This one, when x increases, y decrease, so there is a negative correlation, and r is equal to -1, and since it's line passing by the points, we called it a perfect negative correlation. With the fourth case here, we have no correlation whatsoever, because the points are so scattered that we cannot control the line, or we cannot control the relation. There is no relation between x and y, and based on that, r is equal to 0. Also, we can use what's called linear regression, which is a technique that estimates the relationship between two sets of data by fitting a straight line to the two sets of data values. The regression will show me if those points, or the variables, the different variables, have a relation with each other or not. To do that, we create an equation, or there is an equation to calculate the regression variable, and the equation is y equal to a plus bx. And as you know that from the math and the courses that you took in math, this is the equation of line, straight line, and a is the intersection or the y-intercept, and b is the slope. So to find b, this is b, this is the equation for b. Basically, we are finding the slope, but we do it using the summation of the variables that I have for x and y, the values, minus n multiplied by x average, y average, divided by the summation of x squared minus n multiplied by x average squared. And the a value can be we can get that by adding or by subtracting the bx from the y average, bx average from the y average. The last thing that we need to look at is normalization, or normalizing data, which is a technique that we use to bring data characterization or characters to some common or standard level, so that comparison become more meaningful. The meaning here is sometimes you have the data in thousands or millions or hundreds of thousands, so you have lots of zeros that you can not eliminate, but you can normalize, which is, maybe tone it down a little bit, so it will be more meaningful. For example, if I have here a function area A that has 76 severity and composed of 3,300 lines of code, and this is in software programming, while function area B has 98 severity and composed of 5,400 lines of code. So to find the error or the defects per line, we divide the severity by the 3,300. When you do that, you will get a very small number, which is 0.023, and that's a very small number to compare or to understand. We cannot say that we have like a fraction of defect per line of code, a fraction of defect, while I can convert that or normalize it in a way that it will be in thousands. So I will say that this one actually is 3.3 thousands of lines of code, or KLOC. K means thousand, L line, O C code. So this is the measure or the unit that I will be using. And in this case, what we did, we divided the severity 76 divided by 3.3, the same as we did up here, but we toned the thousand down a little bit, and by doing that we got 23 defects, and the 23 defects is per 1000 line of code. We will do the same for the functional area B, and we will have 98 divided by 5.4, which is equal to 18.1 defects per 1000 line of code. So now I can actually measure or compare the two functional areas and say that, functional area A has more defect per 1000 lines compared to functional area B. And like I said, this is the normalization is a technique that will assist in getting the results more comparable, or easy to compare, or easy to understand, and more of meaningful results. We are doing all the data collection, data analysis, understanding the data, creating the charts, creating all these outcomes or results using many techniques, just to generate what we call the management report or the project reports that's needed to either report to the upper management or to report to the client. So once I have all the data analyzed, reports are being generated for the ongoing project monitoring, and reports will be submitted to managers and executives to make sure that the project is going as planned. If not, then a decision will be made to do a corrective action, as we said before. Reports will help to understand how things are going and manage the project better. It can be used to compare different options, different alternatives, making sure that the proper solution is being implemented as planned. And then it's made to describe trends and understand patterns of data within the project and during the execution. In the next session, we will talk about how to present the data that's being collected to the upper management. What kind of technique can be used for presentation. That will be all for this session. If you have any questions, please email it to me. Thank you and have a great day.